Somebody here. All right. So good morning, everybody. Hope everybody's doing great. Hope everybody is all right. Last class we knocked out B1, B2. Today we'll just look at B3 and go from there. Mhm. Let's just jump in. Relatively short section as well. So it's just an introduction to equations. And remember last class we talked about expressions. Those are just you know, containing variables, sometimes operations, numbers. When it comes to an equation, though, you have to have an equal sign involved somewhere. So it's just a statement that two expressions are equal. So once again, also, while you guys get started with writing your notes, make sure you're getting into WebAssign. If you can't, shoot me that email. Let me know that you're not in there. They're supposed to be working on trying to get it fixed. They know it's an issue, just trying to figure out what it is. So the more people that can let me know, the better. Yes. You don't have to create an account. Yep. So a couple examples of equations. 9 plus 3 is equal to 12, of course, but that's an equation. 3x plus 2 equal to 10. Y squared plus 4 equal to 2y minus 1. And then x plus 5 equal to 7. That's, yes. They're just examples of what an equation is. That's it. Yeah, that's it. We ain't done that with them yet, though. I said we haven't done anything with them. I'm just showing you what an example of an equation. Yeah. Yeah, it's nothing for you to understand. It just that's what an equation. If it has an equal sign in it, something on this side, something on this side, and there's equal sign, that's an equation. That's all I'm saying. Yeah. But we about to do something with it now. Yeah, yeah. We about to do, you say you did what now? Oh, okay, yeah. But yeah. Now we don't know what X is right now. So X is unknown. Remember, our variables represent unknown numbers. So we have to, eventually we'll be looking at solving and figuring out what X is to make that a true statement, but we haven't gotten that far. All I was just saying, this is what an equation is like. Yeah, it's all good. It's all good. We getting there. So, as your classmate mentioned, when we're looking at these equations, at some point we're going to get into solving and actually finding a solution. So if you want to find a solution of the equation, you actually want to ask, when is this equation true? So when I look at x plus 5 equal to 7, and I want to solve for x, I want to know what value for x will make this a true statement, or in other words, when is x plus 5 equal to 7? So we're looking for the solution. So that's going to be a value or values, depending on the complexity of your equation, that will make your equation true. So in other words, x equal to 2 is an example of solution, because 2 plus 5 is equal to 7. All right. So when is x plus 5 equal to 7? When x is equal to 2. And so you see my little red statement right there. And if you have anything that is a solution, that you believe is a solution, you always can plug it back into the equation to see if it makes a true statement. So like I said, 2 plus 5 is equal to 7. And of course, if you've never dealt with solving equations before, we're not going to be sitting around here guessing on what the solution are. There's a process, but I'm just telling you, just give you an example of what a solution is. It's a value that will make your equation true. So before we get into the solving, everybody hold on, everybody okay with the top? Okay. So before we get into solving, what we're gonna do is make sure we're okay with actually plugging it in and making sure our equation, our solution is true. So if they give you a value and ask you, is this the solution for the equation? Are you able to determine? So basically what you're gonna do is they'll give you an equation, they'll give you a value, you plug it back into the equation. If it ends up giving you a true statement at the end, then it is a solution. If not, it's not a solution. So our first equation is 2x plus 5 equal to x squared minus 3. And they give us -2 that they want us to check. That's just a semicolon right here. That's all. So this is our equation I'm looking at. So this is my equation. And this right here is the solution they want us to plug in. So we're going to plug -2 in wherever we see x. So notice we have x in two different places. So we're going to plug in that -2 into both spots. And that's what I did in that next line. So you see we have 2 times -2 plus 5 equal to -2 squared minus 3. So make sure we're okay with the substitution. All I did was take -2 and plug it in where I saw x. So we had x in, once again, we had x in two different spots. So we had to plug -2 into both places. And then from there, we do the math, like we did last class. We did 2 times -2 is -4. And then over here, there's -2 squared is -2 times -2, which is a positive 4. And then over here on the left, -4 plus 5 is 1. 4 minus 1 is 1. But 4 minus 3, excuse me, is 1. And now you see we have a true statement. 1 is equal to 1, which is true. So that means, yes, it is a solution. And again, yes. So you have to come down and have both numbers equal be the same number. Yep. And screw it up. So next one, 7 minus 3n equal to 2. And the value you want to plug in is 2. So that's a possible solution. So the 7 minus 3 times 2 equal to 2. And so we have this 3 times 2, which is 6. 7 minus 6 is 1. So that's 1 equal to 2, which is not true. So that means it's not a solution. All right, you good? Can you scroll up? Mhm. And I was look at actually trying to solve equations. In fact, basically they would not give you the solution. You just have the equation and then you want to solve for the actual solution itself. Anybody holding on to that last example? Mhm. So to solve equations, what we're going to do is use the opposite, what I call opposite operations. Basically, those are operations that undo what the other one does. So examples of that: addition and subtraction are opposite operations. Multiplication and division are opposite operations. And then the other thing that we have to consider is that whatever you do to one side of your equal sign, you have to do to the other side in order to keep your equivalency. So if you're going to add something on one side of your equal sign, you have to add that same thing to the other side of the equal sign. Let's see, buddy. All right. So let's go to that x plus 5 equal to 7. And we already know that the solution is 2, because 2 plus 5 is equal to 7. But what we want to do, you see my little blue box right there, is that the goal is to get x by itself on one side of the equation. So whatever is being done to x, we want to undo that. So we have x plus 5. So what I should be looking to do is to minus or subtract 5. That's how I really it. Because plus 5 and a negative 5 will cancel out. So to keep my equivalency though, we have our equal sign right here. Whatever I do to the left side, I need to do to the right side. So if I minus 5 on the left side so that my 5s can cancel, I need to minus 5 on the right side as well. And so on the left side, all left with is x. And then on the right side, I have 7 minus 5, which is 2. And that's my solution. So that's the foundation of solving equations. Once again, your goal is to get your variable by itself on one side of the equation. And in order to do that, we need to use opposite operations. But once I use that opposite operation on one side of the equation, I do it to the other side in order to keep my equivalency. And keep doing that, eventually you will get down to your solution. Questions on that before we do a few more one-step equations? Make sure you all right. Let me erase these just to make sure you're okay with them. We'll walk through. All right. So y minus 10 equal to 30. I want to get y by itself. So in order to do that, I need to add 10 to both sides of my equal sign. The 10s cancel, and I'm left with y equal to 40. Everybody all right with that person? Yep, my goal is to get y by itself. So in order to do that, I need to move this -10 or this -10. So to undo the subtraction of 10, I need to add 10 so that it can cancel out right here. But if you add 10 on the left side of the equal sign, I need to add 10 on the right side of the equal sign. Well, that's why I got 30 plus 10, which gave me 40. That's my final answer. Yeah. And this, like I said, this section is just an intro to equations. So we'll do a few more that has a little more to it, but we're not going to really get deep into solving equations. Not too deep. So the next one, we have 5a equal to 13. Remember we mentioned this last class, whenever a number is right up against a variable, that's multiplication. So 5a means 5 times a. So in order to in order to undo the multiplication of 5, I need to divide. Yep. And if I divide on this side, I have to divide on this side as well. Fives cancel. Remember, 5 over 5 is just 1. So it's 1a. And then I have 13 over 5 as my answer. So now notice 13 over 5 was left that way. You don't have to convert it to a mixed number or a decimal. Um, leaving it like that is fine. Now you are expected to reduce fractions. Converting a fraction to a decimal and reducing a fraction are two different things. So you can leave a fraction of 13 over 5, but down here, let's say if I have 4 over 6, I'm just using this as a random example, y'all. So let's say if my answer came down to 4 over 6, you are expected to reduce that. So reducing a fraction means that if those two numbers have something in common, then you can break it down with that what that number that they have in common, cancel it out, and you have a number that's reduced down to its simplest form. So 4 is 2 times 2, 6 is 2 times 3. Notice they have a 2 that's in common. So those 2's can cancel, and that'll leave you with 2/3. That's reducing. So that is something you are expected to do. Converting this to a mixed number or taking it to a decimal, you're not expected to do that. You don't have to do that. So just make sure we understand the difference between reducing the fraction and doing something else. And they're not going to say anything about it. They'll just, well, the homework probably will say, you need to reduce it, but a test actually could mark it wrong. So just make sure that you reduce your fractions where possible. Mhm. Questions before we look at that last one on the right? Make sure we're okay. So we have x divided by 9 equal to 11. So that's division. I need to get rid of division by multiplying. So I will multiply both sides by 9. 9 cancels, leaving me with just x. And then on the right, 11 times 9 is 99. Swelling up, swelling up. Okay. You know how to get some fractions in there. Make sure you are all right with those. Let me erase. All right. So one I saw in the examples was like this: x minus 1 over 7 equal to 4 over 7. But just because you're dealing with fractions does not mean you change the thought process. I have x minus 1/7. So what I need to do is add 1/7 to both sides of the equation. So don't let the fractions, get you nervous or whatever. You still stay in thought process, just that you're dealing with fractions. So now the 1/7 on the left will cancel, leaving you with just x. And then on the right, we have 4 over 7 plus 1 over 7. That gives you 5 over 7. Mhm. So the next one, we have 5/9 y equal to 10. So of course, that's multiplication, so we will be looking to divide. Now, the thing about dividing by a fraction, whenever you divide it by a fraction, you're actually multiplying by the reciprocal, and that's that fraction flip. So we can just go ahead and do that. Whenever you have a fraction sitting in front of your variable, just go ahead and multiply both sides by that fraction flip. In other words, it's inverse. And what that will allow to happen is the 9 will cancel because you have 9/9. And then the 5 will cancel because you have 5/5. Because you're multiplying by that fraction. And whenever you divide it, because remember, in order to get rid of that 5/9, we have to divide by 5/9, right? So whenever you divide it by a fraction, let's go here. Let's say if I have 4/6 divided by 5/9. Whenever you divide it by a fraction, that changes to multiplication, and then you have to flip it. So that's where that comes from. Whenever you divide it by a fraction, you have to flip it and multiply. And so that's what we're doing right there. We just go ahead and skipping that part and just multiplying by the reciprocal. So whenever you have a fraction sitting in front of your variable like that, just multiply by that fraction flip. And you notice, you see how it cancels out. And so that's what we wanted to happen. Oh yeah, we didn't finish it. All right, so then finish it off 10 times that 9/5. All I did was just multiply the 9 times the 10, which is 90. And then 90 divided by 5 is 18. Mhm. Hold on. Look at this. So if I got two of these, yep, I just got two. And then yeah, we'll be done with that for right now. Everybody get these from scroll up. So just add in one more step to the process. So let's say we have 2x plus 3 equal to 17. All the ones we've done at this point only have one operation. Notice now we have 2 times x plus 3 equal to 17. So once again, our goal is to get x by itself, and we need to do opposite operations. The easiest way to do this is to move the terms that are not connected to your variable first. So when I look at 2x plus 3, I will be looking to move the 3 first. And the way we'll do that is by subtracting 3 from both sides. So on the left side, the 3 cancels, leaving me with just 2x. And on the right side, 17 minus 3 gives 14. All right, so 2x equal to 14. Now I can just divide both sides by 2. 2's cancel. And that'll be x equal to 7. Any problems with that? Make sure you're okay. All right. Next one, just have some parentheses involved first. Notice we have 2 different x terms, but we can't combine our x terms or our like terms until we get rid of that parentheses. So we distribute the 2. And that's what, oh, all right. So right here, distributing 2 into the parentheses. So that's 2x minus 8 minus 5x. So that's what we have right here. Now combining like terms, 2x minus 5x gives me this negative 3x right here. Everything is still there. We got the minus 8 and the negative 5 over there. Everybody so good so far. So now we're right here, which is the same scenario that we had in our last problem. So the first thing we need to do is move that 8. So we have a minus 8. That means we need to add 8. 8's cancel, or at least on the left side, and that gives me negative 3x. And then on the right side, negative 5 and a positive 8 is a positive 3. And then divide both sides by negative 3. X is equal to negative 1. All right, questions? All right, let's see. How many students do you want to do? Yeah, we got 20. Yeah, we should be able to finish that. All right, just want to make sure. All right, so that's the extent of equations that they get into for this section. Like I said, it doesn't get too deep. I think we're gonna come back to it in some later sections. But once again, it's a new book, so I haven't went all the way through it yet. So we'll get there when we get there. Or maybe that's all we got. It's all good, no matter what. So next thing we're looking at are just some basic percent problems. So when we look at these questions that they give us, if we look at the words and apply them to symbols mathematically, we'll be able to set up an equation for ourselves. So what is always going to represent our unknown or our variable is going to be our equal sign. Of in mathematics means multiplication. And then when we look at our percentage, we're going to convert it to a decimal. And that means we're going to move our decimal 2 places to the left. You'll see in a second. Just give me a chance to write that down. All right. So 7.5% of 40 is what number? So when we look at converting a percent to decimal, we're gonna move our decimal 2 places to the left in order to convert it. So that's what I did right here with that 7.5%. So if I look at 7.5%, that's what I was talking about right there. So just move your decimal two places to the left, or convert percent to decimal. So it gives us 0.075. Like I said, of is multiplication. 40 is just 40. Is equal, and what is our x? So it just means 0.075 times 40 is 3. So 3 is 7.5% of 40. You all right? What part? Okay, okay, let me know. I saw it was written on your face though. You were processing. Well, that part right there though, the only real work that we did that I didn't show is something I'm willing for you to just throw in the calculator. That 0.075 4 times 40. So that's what I was wondering, was that part? Yeah. Yeah, we're past the arithmetic part of math. We're in algebra, so they're not asking you to do the long multiplication process. So you can throw that in the calculator. As long as you got the setup and you remember what is that be okay. Other than that, I would have walked y'all through that if I really want y'all to be on it like that. All right, next one. What is 25% of 800? So once again, what is our variable? Is our equal? 25%, moving that decimal 2 places to the left, which is 0.25. Of is multiplication, and 800 is 800. I didn't put that up there. 0.25 times 800 is equal to 200. That'll be it. I sure got one more just to make sure we're all right. And one more like this. So 20 is what percent of 32? So if you look at the first two, notice the x is already on one side by itself. In this case, you're gonna have to solve for x by doing one extra step to finish it off. So 20 equal to x times 32. So x times 32 is the same thing as 32 times x. When we talk about a commutative property, x times 32 and 32 times x are the same thing. All right, so we have 20 equal to 32x. Divide both sides by 32. 20 divided by 32 is 0.625. And WebAssign lets you know if they want the answer in percentage or not. Since this one said what percent, they may want your answer in percent. So if that's the case, remember to go from percent to decimal, move the decimal 2 places to the left. Not to go to decimal to percent, you just move the decimal 2 places to the right. And that'd be 62.5%. Any problems, any problems. Okay. We got one more concept to introduce, and then we'll be done with this section. Yep. Straight. What part? What's up? Now, what step you talking about here, or what step are you looking at? Huh? Okay. So now coming from here to here, we just use what it means. Words in math mean something. So these words, this is what these words mean mathematically. So 20 just is what it is, but the word is means equal in math. The what is your unknown, so that's your variable, but of means multiplication. Uh-huh. Yep. Yeah, no problem. All right, anything else on this one before we scroll up? Good. Mhm. So last concept for today, we look at percent increase and percent decrease. You find both of them pretty much the same way. First, if you're trying to find a percent increase, you find the amount of increase divided by the original amount, then multiply times 100%. Find a percent decrease, you find the amount of decrease divided by the original amount, and then multiply that by 100%. So find a percent increase in the federal debt from 2005 to 2010. So these two values came from a chart. So, the chart doesn't matter. We have the numbers. That's all we need. So in 2005, the debt was 7.91 trillion, and then it went up in 2010 to 13.53 trillion. And you want to calculate the percent increase. So first thing we need to do is find the amount of increase, and the way we do that by subtracting those two numbers. So 13.53 minus 7.91 is 5.62. And now you take that 5.62, place it over the original amount. The original amount was 7.91. So that's 5.62 divided by 7.91. That gives us 0.7104. And of course, Weber sign will let you know how many decimal places to go out or whatever. They just want one decimal place or whatever. They'll let you know. But I went out, the 4, so I can have 2 in our percentage. So 0.7104 times 100 gives you 71.04%. And that is your answer. That's your percent increase. Any questions? Any questions? Make sure you're all right. So these type of problems that you follow the process, you should be all right. Start the calculator. Say that one more time. Yes. Mm-hmm. How did you say what? Throw it in the calculator. Yep. We're not, I'm not holding y'all to not the law of subtraction process, but you're talking about 13.53 minus 7.91, set it up that way. In which, 3 minus 1 is 2, and that's gonna be 15 because you borrowed. And so 15 minus 9, 6. And then you got 12, so then you have to borrow. 2, so you have to borrow, and that's 12, and 12 minus 7 is 5. Yeah. But like I said, we're not asking for that necessarily. You can throw that in the calculator. But I do want to see some, like I said before, some of your steps, but you don't have to show me every single detail like that. Now, if you want to do that, feel free. I ain't taking nothing away from you. But yeah. And then just to make sure we're okay with the percent decrease, it's the same thought process. So I just switched some numbers up. Just said, okay, if in 2005 it was 10.9 and it went down to 6.4, there was a decrease. So what is the percent decrease? It's the same process. You're going to subtract those two numbers. So it's 10.9 minus 6.4, which will give us 4.5. But you always going to place it over the original amount. This time the original amount is 10.9, the larger number. So that 4.5 over 10.9. And then times about 100 will give you 41.2%. So once again, the process is take your two numbers, subtract them from each other, divide by the original amount, whatever the original amount is, and then multiply it times 100. And that will be your percent, whether it be increase or decrease. Questions, concerns, comments, anybody? Make sure you're okay. I think that was it. Yep, that's it for that section. So, in WebAssign, for every homework that we talk about, there's a homework. Every section that we talk about, there's a homework for it. And now the first assignment that you may see, I forgot what it's called, but it's something that talks about, or addresses problems or types of problems that you should be okay coming into the class with. And, like fractions and stuff like that. Try it out. I know some of you have, some of you emailed me about questions on it, and you just got to get me on that. We in the process of setting some stuff with certain people up now. But if you have questions on those things, make sure you get with me so you're good to go moving forward. That does not mean you cannot go to B1 if you're not comfortable with that first assignment. What you see in B1, B2, B3, you comfortable with that? You go ahead and knock out those, and we'll get to the problems that you have. Whenever we able to work out the time. You shouldn't need a course code. It's actually for a course code. So now, did you log in through Blackboard and then go through website? You said you didn't. Yeah. See, now that's gonna ask you for money. So go through Blackboard and then go through WebAssign so that you don't have to pay. And then it shouldn't ask you for a course code either. All right. So anything else? Anybody else before we close? Everybody good? Great. All right. Yes. Yeah. Uh-huh. Yeah, because what has happened to me in the past is that I have people come to class every day, then they'll do the work in WebAssign or MATLAB, whatever computer component, and then I'm just like, you're gonna fail. Like, so I'm trying to push people into the WebAssign, because you got to do WebAssign work or you most definitely won't pass. So I don't want to give anybody a false sense of security. Like, you haven't come to class every day, but it don't matter if you ain't doing no work. You know what I mean? So, yep. So yeah, I'll be looking at your attendance through WebAssign, but everybody's not in yet. So it's not like I'm like, y'all gonna fail because you ain't in there yet. So I need y'all to get in there though, so we can make sure everybody's good. So all the assignments on WebAssign, right? All the assignments are on WebAssign, but you have to go through Blackboard to get to WebAssign. I'll show you in a second. So yeah, so you have to go through Blackboard to get the web assignment. So you're right, you won't see any of your assignments in Blackboard. But when you go into Blackboard, you'll see the web assign link. Click on that web assign link, and then you'll get into web assign. Right, right. Yep. All right. Anything else? Anybody else? Oh yeah, and yeah, if you see that thing talking about syllabus quiz, don't worry about that. I don't quiz people on syllabus and syllabi and all that stuff. But that's something that was in there. So if you're somebody who got an error, then email me. The reps are supposed to be trying to figure it out because something I got like 13 to 15 people that are actually in WebAssign. Then I got the rest of people who cannot get in for whatever reason. I don't know why they're trying to figure it out now. So just email me and let me know you one of the people that could not get in, so I can let the reps know, and they can know that it's the issue they still need to work on. Yep, yep. But as of right now, you guys all good. Remember, I told you your first due date is not coming up like within the next day or so. It's going to be 5th week grading. So we got a little time to try to figure out this WebAssign thing, try to figure out why everybody's not getting in. So you're not going to have anything due till 5 weeks from now. The key is not to wait until 5 weeks to actually start doing it. All right. Anybody else before we close? Everybody good? Straight, straight. All right. Y'all have a good weekend. Be safe, and I will see y'all Monday.